Yeah, comes on everyone. Yeah, comes on. So let's start off. So this was the last thing that we did. A block is toppling over a obstacle. Similar question. Let's say we have a solid cylinder, mass and radius are. This is going with V and omega. The height of this step is, let's say, R by 4. Take it as R by 2 will be too big, I guess. Okay, we'll take it as H. And E is equal to 0. That means when it is going to hit this step, it is going to, it will rotate about this point here. So let's call this point A. The cylinder hits the step and rotates about A. Basically, E is equal to 0, it sticks. Find V minimum so that it climbs the step. Same as the previous question. Previous question, the obstacle was almost negligible. Now it is not. Able to visualize, right? What will happen? This will go here. It will hit. Once you hit here, this is how it is going, see. It will just start climbing over this point. It will just go up on that. Get this? How do we proceed with this? Quite a lot of similarities with this. Basically, a body which is rolling will become pure rotation about that. Point A will become the IAR. Oh, 1 second. While seeing the notes again, I found some mistakes actually. Yeah, we can add angular momentum also. There's one more mistake also. Is this? Yeah, this is the right one only. ठीक है. Try. How do we proceed with this? Did everyone give the test? Hit to give. I'll give a test for the reattempt also. It's a good paper. I hope you have seen it. But do try it again. Meaning that's a reattempt. So you won't get marks counted for that. That is only for your practice. Only the first attempt will be there for marks. Chalo, let's try this. What happens, Aina? You worked hard and gave the paper. ऐसा कुछ है? Chalo, let's try this. Venkatesh, Shaurya, keep your cams on. Lakshmi, after a long time, we are seeing you. I know you're busy with the thing. I hope you have seen the recording though. No? How do we do this? Let's finish it off today. We'll be finishing off rotation today. What is step one? Conserve angular momentum boat. So initially cylinder was here. So once it hits this obstacle, it is just losing contact actually. It is just above the floor. This is just before losing contact with the floor. So this is V and omega. So about this point A, this thing starts going in a pure rotation omega dash, isn't it? So torque about A is 0. So L bar about A is conserved. You said the step ka height is h. So what is the perpendicular distance? Extend the vector and drop the perpendicular. So this distance will be r minus h. L initial is equal to L final. So L initial will be mv, perpendicular distance r minus h minus k cap plus ICM omega minus k cap. L final will be moment of inertia about A into omega dash minus k cap. You just conserve angular momentum about point A. So since it is sticking at point and rotating, it becomes like a pure rotation about A. It's like a hinge. So mv r minus h plus solid cylinder, so mr square by 2 omega. IA will be mr square by 2 plus mr square, 3 mr square by 2 ओमेगा डैश. तो यहाँ सॉल्व करेंगे तो ओमेगा डैश आ जाएगा. Check your steps. And remember, you can't conserve energy. Why? Since it is hitting and stopping, right? It is sticking there. That is E0, perfectly nice collision it is. So whenever someone says it sticks about the point, it rotates about that point, meaning it is getting stuck there. There will be a deformation. Energy can't be conserved. Here, energy is not conserved before and after colliding with A. Once the collision is over, energy is conserved. You hear the word sticks, matlab gaya, there's a deformation. Since it sticks to A, there is a deformation. This is inelastic collision. Clear with this step? Then what? Now, after this point, so this is omega dash. Since you want to just climb the step, this is what would happen. Meaning you just reach here with omega 0. Just comes to rest at the topmost point. Just climbs the step. Where is the center of mass? Here, R. Where is this center of mass? R plus H. So, mgr plus half moment of inertia about A, omega dash square will be equal to mg r. There is no kinetic energy. Omega dash ka value you know from there. Substitute, you'll get the answer. How much is this omega dash? Numbers are bad. 2v by 3r square r minus h plus omega by 3. You have to take this omega dash and substitute here. And if you solve this, you'll get the answer v from here. Please check. The energy is conserved after collision because after the collision is over, all forces are conservative. There's no slipping, so there's no dissipation. Mg gravity is fine. Isn't this looking like this only? Similar problem, right? Only thing there is a step. Please check the steps. This is a first thing, conservation of angular momentum before and after collision. Then energy conservation after collision. Anyone not convinced with any particular step, please ask. Clear? Saina, clear, no? Ishan, Pratyush, Venkatesh, got this? Ronak, clear with this?
Yes, sir.
Nehan, Ayut, clear. Aryan, got it. Let's see, next one. We have a disk, rough ground mu, mass m, radius r. This is given speed v, and omega is 3 by r. Find the final speed. Time taken. for it to stop slipping. Time taken to come back to initial position. Let's get this. This is not pure rolling. If you observe, the velocity at the bottommost point is not zero. It is v plus 3v, 4v. You know how do you get this kind of velocities? Did you ever play carom board like this? You take the coin and keep it like this and put your finger on top of it and you press it down. Kabhi kiya? So what you're doing, when you press like this, you're giving omega this way, but you're pushing the coin forward. So, if you observe what happened, the coin will go forward and then comes back again. You're getting how it is? Put the coin vertical on the table. Carom board coin works well. Put your finger like this and press it hard down like this. So this coin will go forward, translating, but rotation is in the opposite. It skids and goes forward and comes back. If you're a good carom board player, you will not know these things. If you are someone like me who doesn't know how to play and mess up things, we'll do this kind of nonsense. Helps. So let's see how to do this. First part is fine. We can use angular momentum here, or I can use normal force equations also. But let's do with angular momentum, that saves time. First thing seen. When this guy is skidding, what are the forces? I'll show you how to do it both the ways. I'll give you this thing. You can try. Since it is slipping, I'm sure the friction is maximum here. So this is F max. That will be mu mg. From here, you can find the acceleration, which is mu g. This will also generate alpha, which is now you can't take torque about point A because there's non-inertial frame. Torque about center of mass will be F max into R is equal to I COM alpha. From here, you get alpha. And then you write V final is equal to V minus mu GT. Omega final is omega minus alpha T. And then you write V final is equal to R omega final. This is one way to do. यहाँ से time आ जाएगा and V final भी आ जाएगा. But this is long. Faster way is this. This guy is going with V and rotating with omega. Agreed, there is a frictional force here. N here. Mg here. So if you take any point on the floor, torque about A is zero because friction is passing through that. Therefore, L about A is constant. So as this guy is rolling, eventually, let the velocity be. I'll assume forward only. Let's see what happens. You'll get signs reverse. Omega dash and V dash. So initial angular momentum is equal to final angular momentum. So this is the condition when it stops slipping. So V dash will become equal to R omega dash here. So initial angular momentum about A, angular momentum of center of mass mvr minus k cap plus ICM omega. It's a disk. I is mr square by 2 omega plus k cap. Finally, when it stops slipping, mv dash r minus k cap plus mr square by 2 omega dash minus k cap. Signs are important. Be very careful when you take angular momentum. Substitute the values. mvr minus, this guy would be, what is initial omega? Omega is 3v by r. So r omega is 3v. This is 3 mb r by 2 is equal to minus mb dash r minus mb dash r by 2. This is mb r by 2 is equal to minus 3 by 2 mb dash r. V dash is minus v by 3. As expected, it is actually going backward. Particle is not going front, it is coming back. V dash aa gaya. If I know V dash, I'll get omega dash also. That will be minus v by 3 omega r. The coin is actually coming back. Have a look at this. This is faster using angular momentum. You just need to find initial final angular momentum and equate them. यहाँ पे you'll get it. You have to write force and torque equations here. F is equal to ma. From here you get a ka value, alpha ka value. Then use v is u plus at, omega final, and get it. Both will work. But how to get time from here? Let me show you that also. Time part is easy only. So time part, we use this thing. V final is equal to v is v final is v initial plus at. So v final is minus v by 3. V initial is v, and this is minus mu gt. So time will be 4v by 3 mu g. That's your time. Direct aa jayega ek step. Once you know final velocity, you can find time. V is equal to u plus at. Remember, v dash has become negative. So alternate method is something which I like, saves you time. But angular momentum you have to calculate properly. Most people that I see na, they don't take care of this sign. They just add it up randomly without taking signs. We'll goof up the answer then. Hope everyone getting the direction. Translation ka aisa hoga angular momentum. Rotation ka it is opposite. That's why you're getting a sign reverse. Please check. So I did first two parts. Final speed, time taken to stop. Now if the velocity has become backward, what will happen? It will go front and come back now. Find the time taken to come back to the initial position. How is the center of mass angular momentum minus k on the RH? I assumed omega dash this way, na? See, I assumed omega dash clockwise. So that's the reason, say, I got signs wrong. You assume whatever direction you want, the signs will take care of it. I assumed front, but I got negative. Please check, question is still not over. Find the time when it comes back to the initial position. Anyone not clear with this page, please ask me. There are two ways you can do this problem. Anyone not clear with this, please ask. How do you find the time taken for it to come back to the initial position? You're getting different answer using first method. Alpha कितना आया था?
Sir, 2 mu g by r.
Mu m g r या m r square by 2. हाँ 2 mu g by r ना.
Yes.
This guy will be v minus mu g t. This guy would be omega minus 2 mu g by r t. If I substitute here, I get v minus mu g t is r omega minus 2 mu g t. R omega is how much? 3v. Did I mess up some calculation anywhere? That is okay. I messed up here. ये भी minus था, isn't it? You took alpha this way, na? But omega was initially this way. Right, Pratyush?
Yes, sir, got it.
Omega initially भी negative था actually. Because we took clockwise as positive, this omega initial is negative here. Omega initial is minus omega. अभी आएगा आंसर. ठीक है? What about the time taken to come back? See, that is हो गया अभी question. So this is v. Acceleration is mu g. So finally it will stop slipping. This is a pretty good one, right? This is a pretty good one. What is the mistake? क्या करना था? I was planning to do something, then I suddenly remembered something. When will it start turning back? It will not turn back when it stopped slipping, isn't it? As it is going front, ये scenario था देखो. Somewhere here, it will keep going front. At somewhere here, v becomes 0. V becomes 0. But remember, omega is abhi bhi is there. Omega is still there. So let's say this is t0. This t is the time when it stops, is the time when it takes a turn. This is v by 3, and this is your omega, which is v by 3r. Let's say this is the time t2. Let me write it as t1. T2, this is the time when it stopped slipping. Means this guy went like this and came back, and then the slipping stopped. Is that making sense? So first you need to find this distance, no? I don't need it, I guess, actually. This is the displacement S, which is, I'll use ut plus half at square. I don't need it. Luckily, it works out because there's a constant acceleration, which is vt2 minus half mu g t2 square. Okay, that is the time taken to was not slipping. So that will give you the displacement directly. And then the additional time when it comes back again here, that will be t3. So time taken to come back from t2 to this initial position, how much is this? Time from no slipping to initial position. Remember, in this position, right, acceleration is 0 because slipping stopped. So the t will be s by v by 3, isn't it? Speed has become constant, na? Therefore, total time is how much? Total time will be t2 plus 3s by v. T2 is the time when it stopped slipping, and 3sb is the extra time required to cover this distance. And that will be 4v by 3 mu g. S is that distance there, 3s by v. Is the steps clear, everyone? So this thing goes front, it stops, then it comes back. Then slipping stops somewhere here. So then you find the displacement. S is ut plus half a t square will give you the displacement from the initial position to the final position. Distance travel nahi pucha. If you ask a distance travel, that would have been even more fun. Then you have to find the length of this red line. But fine, you can do it. It mostly becomes a kinematics question now. Are the steps clear, everyone? Check it out. You can try this with a carom board coin and see. Let's see one more. Any doubts on this? Anyone not clear with this method, please ask. Next one. Let's see a similar one, little different variation though. We have a solid sphere, mass m, radius r. There is a plank here. 2m. It's a long plank. This is rough. The ground is smooth. What someone did, they rotated this solid sphere with omega. There's no velocity. There's no translation. He rotated the sphere with omega and placed on top of it. Rotating solid sphere is placed on a long plank. Find the final velocities when slipping stops. Rotating solid sphere is placed on a long plank. Final velocity सबका sphere का plank का omega everything you have to find. If you observe here, this bottommost point का velocity is not zero, so it clips. So there's a friction. Again, try to use the angular momentum that gives you answer fast. Try. Initially it slips, na? Initially it slips, right? Initially at the bottom, see what is no slipping? At the point of contact, relative velocity should be zero. Here initially plank is at rest. So initially it is slipping. So eventually something happens and it stops slipping. So what are the velocities? Those are the final velocities. When you say final velocities, उसके बाद velocity change नहीं होगा. That happens when the slipping stops. Anyone not clear with the question, please ask. Others, do keep your cams on. Venkatesh, Ronak, cams on. I told you this thing. Whenever you're using conservation, what is the first important thing you have to do? Draw the final diagram. You're getting these are simple things, which will help you a lot in the exam. Most people that go to the exam, they keep staring at the question, now what? So you should know the starting point. If you're going to use force and torque equation, start with an FBD. Even if you don't know what the hell is happening, start with an FBD. Things will start falling in place. And if you know how to use conservation, the important thing is finally diagram kaisa dikhega. How will the plank go? How will the spear go? If you can figure out that part and draw, telling you 50% of the questions in your hands. Most important thing in physics is visualizing how does the situation look like. Then comes concepts. See the final diagram. See whether you got this or not. And don't worry, like, sir, how do I know which way to? Doesn't matter. Assume any direction. The science will take care of it. But just assume something v1 properly, and let's say this guy is called omega dash. And let this thing be v2. इतना तो assume कर लो. Next thing, no slipping condition. So at this point and this point, velocity should be same. So v1 minus r omega dash is equal to v2. This is equation 1. Next thing, there are no horizontal forces. Means I took something wrong here now. There are no horizontal forces. Initial momentum is equal to final momentum. Initial momentum is 0. The final momentum is mv1 minus plus 2 mv2. That means v1 is equal to minus 2v2. Both are going in the opposite direction. Conservation of linear momentum. Is that making sense? Next thing, if you see friction will be on this and friction will be on this. So if you take about some point A here, torque about A is 0. Therefore, angular momentum about A is conserved. L initial is equal to L final. The plank is so thin, you can neglect the thickness. So velocity is passing through that. Plank will be always 0. The only thing that matters is the sphere. So the angular momentum of the sphere will be, there is no translation, only rotation. That would be 2 by 5 mr square omega minus k cap. This is for the sphere. Plank is 0. So plank P2 passes through A. The final angular momentum, again only for the solid sphere, you will take m v1 r minus k cap plus 2 by 5 mr square omega dash minus k cap. This is your third equation. If I use equation 1 and 2, v2 will be minus v1 by 2. We get v1 is equal to 2 by 3 r omega dash. Take that and substitute here. Two by 5 mr square omega mv1r plus 2 by 5 mr r omega dash will be 3 by 2 v dash. 2 will cancel. That will be 3 by 5. That will be 8 by 5 mv1r. So v1 will be 2 will cancel 4. So r omega by 4. Check. Once I got v1, I'll get everything. I'll get v2 omega dash everything. Check it out. No slipping condition, linear momentum, angular momentum. You can't conserve energy because there is slipping. Let me write that here. Whenever there is slipping, energy is not conserved. See, one thing is clear. In this question, he asked you final velocity. When you hear the word, you know I'm talking about angular conservation. Then you have to check. There are 3 conservations. Can I conserve energy? No. Why? It is slipping. Second thing, can I conserve linear momentum? Yes, because ground is smooth, the friction between them is internal. Can I conserve angular momentum? Yes, because the frictional force will pass through this point, so torque is 0. I can conserve angular momentum. Third, no slipping conditions. 3 variables, 3 equations. Check it out. Anyone not clear with any particular step here? Please ask. Clear? Next one. Clear? Great. Next one. Now, this is another variety of problems. Top view. There is a rod here, mass m, length L. There is a ball here, mass m, coming with speed u and hits the edge. E is the quotient of restitution. So a ball of mass m collides with the rod placed on a smooth horizontal surface. So this is our top view, just like your pen game. Find final velocity. Find velocity of rod, omega of the rod. When I say velocity of the rod, I'm talking about center of mass. And velocity of the ball after collision. Let's get this. This is the top view. It's like your pen is on a table and something comes and hits the pen on the edge. So meaning this is what will happen. This rod now will get velocity v and omega. The rod will actually rotate like this and go. To find v final, omega, and v ball of the rod after collision. Get me the equations. Solving is fine. I just want the equations. We will next questions we'll see some numericals. Main idea is if you got the equations for this problem, you know how to handle these kind of problems. Take 2-3 minutes, figure it out. Yes, torque about point of torque is conserved. What concept is that? Is there any concept called torque is conserved? See, to conserve angular momentum, what do you need? Torque should be zero. About which point? That I don't know. You have to figure it out. If you say torque about this point is zero, then angular momentum about that point is conserved. So your priority should be to find a point where torque is zero. But luckily, if you see here, there are no external forces. Torque about any point is zero. Collision force between the ball and the rod is internal. So there are no external forces. MUL by 2 is ML square by HD. What is this? That is not, there's only one equation, right? God. First thing, what is the first thing that you have to do, everyone? What is the first thing you have to do? Pray to God such kind of questions don't come in the exam. No. Then what? Start shouting in the exam. What the hell is this guy? First thing, what do you do? Draw the final diagram. So this is a rod. This is M. This is U. This is before collision. After collision, let the velocity be V1. Let this guy be omega. And let this guy be V2. Okay? That's your final diagram. Step 1. There are no horizontal forces. Remember, whenever you get rod and ball problems, this is the process. There are no external forces, 0. Conserve momentum. Mu is equal to mv1 plus mv2. Step 2, coefficient of restitution. Now listen, this is important. v2 minus v1 by, when you write u1 minus u2, these are velocities of point of collision. These are velocities of the center of mass. This v1, v2 are the velocities of the point of collision. That means when it is colliding here, this point ka velocity is v1 plus L omega by 2. So when you write the restitution equation, this is how it looks. v2 minus v1 ka place mein should take the rod ka velocity at the point of collision, which is v1 plus L omega by 2 by u1 is 0 because this is u1. This is your u2. This is minus u2. Please check. The restitution equation is important. Because if you remember, in collisions, when you wrote restitution, we wrote it for point particles. तो वहीं पे कुछ problem नहीं हुआ था. But these velocities are actually with respect to the, what do you call it, the points of collision. So that is important. Please check your restitution equation. This is where people goof up. Right, why point? Those are the 3 things. The third one, step 3, there is no external torque anywhere. Torque about any point is 0. So you can conserve angular momentum about any point. Getting it? But my favorite point is the point of collision. But let me show you how it looks on center of mass. If you take about center of mass, so the ball, the rod, L initial, L final. So initially ball is how much? You're talking about center of mass. That would be M, U, L by 2. The rotation will be this way, the plus K cap. Rod is initially 0. L final, M, V2, L by 2 plus K cap. For the rod, it is translating and rotating. So angular momentum of center of mass, that will be 0 plus ICM omega. Then you write L initial is equal to L final. mu L by 2 is equal to mv2 L by 2 plus ml square by 12 omega. The translational component is 0. Since V1 passes through center of mass. But I don't like this center of mass thing, but nothing wrong with it. You get 3 equations, 3 unknowns, solve, you'll get the answers. But the same thing, if I take angular moment over the point of collision, see what happens. If I take the angular moment about this point of collision here, angular moment about A, the ball, the rod, L initial 0. Why? It is passing through the point. Rod 0 because it is not moving. L final 0 because V2 is passing through the point. The rod will be M V1 L by 2 minus k cap plus M L square by 12 omega plus k cap. You get only one single term, and L initial is equal to L final. So when I equate this directly, you'll get V1 is equal to omega L by 6. You get a very good equation here. Check it out. This will be much easier because in this equation, if you see there's a V2 omega, there are multiple variables. You can use either one of the angular momentum, both will give the same. We can take angular momentum at any point. Point of collision is little, it gives you good equations, nothing much. The other reason why I like this, sometimes in the exam they'll ask you a question, after collision, which point has zero velocity? Which point on the rod is at rest instantaneously? Or find IAR of the rod just after collision. Now tell me one thing, just after collision, this guy is going with V1 and this guy is going with omega. So if you consider a point somewhere here, this will have velocity V1 and this will have x omega. For the velocity to be 0, V1 minus x omega is 0. V1 is omega L by 6. X is equal to L by 6. Did you see? So this point here, let's call it B. So this is a point with 0 velocity just after collision. Or this is also your IAR. You get very important points there. Just after collision. So this is IAR. Not only this thing. If there is a hinge at this point, there'll be no normal reaction. By chance, if this rod was hinged there, there would be no normal reaction here. Meaning I can solve this questions, right? Simple question, find IAR. I need not do all this now. If I just want to find IAR, momentum का जरूरत नहीं है, restitution का जरूरत नहीं है. Directly one step you'll get the answer. If I ask you find the point with zero velocity, I can do this directly. There's no need to get anything. No need to write restitution and momentum. Please have a look at this page. Huh, Ronak, got something? Anyone confused, please ask. You're getting why about point A is nice? It gives you relation between V1 and omega without V2 into picture. If you write about center of mass, V2 or omega aega, and again you have to create V1 from here, it does become a little lengthy, but you will get the same answers. So generally, I prefer finding angular momentum about point of collision. You can take wherever you want, but this thing gives you pretty good answers for multiple questions. So basically, in this kind of collision, there are three steps. Step one, linear momentum. Step two, restitution. Step three, angular momentum. Clear with this? Let's see one more like this. Anyone not clear with any particular steps, please ask. Great. Let's see one. This is M. This is ball M. This is PDU. Restitution is E only. Mass M length L. This is going and hitting here. Top view. Find M by M if the ball stops after collision. Find the ratio of the mass of the ball to the mass of this thing so that the ball stops after collision. Can I say this? If two bodies collide perfectly elastically, M and M, they'll exchange velocities. You can't do that. That is defined for particles. Let's get this. The 74th problem is a pretty good one. It's a more general format of, this collision problems. Let's give it a try. Calculate this thing. Answer will come in terms of E. So I can ask a question like this also. Find the condition so that the ball never stops. The answers. One thing I'll tell you. Steps are same. Draw the final diagram. Game starts from there. Draw the final diagram. Try to conserve momentum. Try to use restitution. Try to use angular momentum. Somewhere it comes. Basically, here what I gave you is I give you the final velocity of the ball is zero. V to zero दे दिया मैंने. Yeah, answer is independent of you. First thing, final diagram. So after collision, this guy will be V. This will be omega. This guy has come to rest. Step one, conservation of linear momentum. Mu is equal to mv. Okay, direct. तो V आ गया मुझे. V is equal to mu by capital M. Then this is linear momentum. Then I can write restitution E. You should take velocities at the point of collision. So this guy ka velocity is V plus L by 2 omega. So it is V2 minus V1. So V plus L omega by 2 minus 0. Ball is not moving. U1, U minus 0. The rod is not moving. This gives you V plus L omega by 2 is equal to EU. That's your equation 2. Then I will take angular momentum about this point here. L initial, L final, the ball and the rod. Initially 0, finally 0. Initially rod is 0, finally MBL by 2 minus K cap plus ML square by 12 omega K cap. So this also has to be 0. This gives me V is equal to omega L by 6. Take this guy and dump it there. Put it in this equation. And this would be omega L by 6 plus omega L by 2 is equal to EU. No, I don't want omega actually. I want V. Na? So V plus omega L is 6V by 2 is equal to EU. That would be 4V is equal to EU. And what is V? 4mu by capital M is equal to EU. So therefore I get M by M is equal to 4 by E. There. How did you get omega L by 12? There is a 2 there. This distance is L by 2, everyone. Okay, na? M by M is 4 by E. So I can even say something like, so E ka value will be 4m small m by capital M. This should be always less than equal to 1. So for this condition to happen, M by M should be always greater than equal to 4. So this scenario will happen that the ball will stop if M by M is greater than equal to 4. If this ratio is less than 4, do anything you want, ball kabhi rukega nahi. Got the steps? Check it out. So M by M should be always greater than equal to 4. That's your answer. You want in terms of E, that is 4 by E. If E is equal to 1, you'll get 4. If E is equal to half, you get 8 and so on. Please look at the steps. I did the same thing. Momentum, restitution, angular momentum. 3 steps. Let me give any variation, the story will be the same. Clear? So let's see one more like this. I hope everyone is getting this rod problems, rod and the ball collision. The steps are the same. Linear momentum, angular momentum, restitution. Clear? Turn in the page. Lakshmi, clear with this? Ekanksh, Pratyush, Niranjan, Aryan, Vihan, clear na? Sharja? Perfect. Next one. Rod here. Mass in, length L. We have a ball here going with speed U and collide somewhere here. This distance is L by 3. Restitution is E only. Find IAR, or the point on the rod with zero velocity just after collision. Get it? This is easy. Remember what I told you? If someone asks you find velocity zero, you just started only one equation. Angular momentum over the point of collision, you'll get the answer. वो linear momentum, restitution, कुछ जरूरत नहीं है. The point of collision is the best. Try. You want a minute? Hmm. L/4 क्या हो सकता है? Final diagram. After collision, this guy will go with V2, this guy will go with V1, this guy will go with omega. This is the point of collision, so I will take about angular momentum about A here. L initial, L final, the ball, and the rod. If you say every time you write it detailed so that you don't goof up, even if there's a mistake, you'll know where the mistake happened. Ball is initially zero, finally zero, rod zero. There is one more best part. I just need to calculate for the rod. MV2 L/3 direction is minus K cap plus ML square by 12 omega K cap. This guy also should be zero. So by now we will get V2 is equal to omega L/4. Right, Sino? You got it. So if you take this point going with V2 and this guy is going with omega, there'll be some point here, V2, and this will be x omega. Let's assume the distance is x from here. The V2 should be equal to x omega. So point at L/4 above the center will have zero velocity. That's your IAR. Check. If they just want you to find the velocity, you'll get it in one step. Clear, everyone? Let's see one more. Going ahead, Venkatesh, come on. Again, top view. We have a rod here, mass and length L, going with speed U. And there is another rod here, same thing, mass and length L at rest. This thing comes and hits the edge and sticks. And the shape becomes like this. The rod collides at the end and sticks, forming an L-shaped rod. Find velocity of center of mass and omega of the system. System is that L-shaped rod. Meaning iska pura velocity of center of mass and the omega. Get it? Rod colliding with rod. This looks scary, but it's actually manageable. Think, I'll give you 2-3 minutes. Velocity of center of mass is easy, right? You can see and tell the answer. Tell me one thing. During collision, will the center of mass get affected? No. The initial velocity of center of mass is final velocity of center of mass. Isn't it? The mu by m plus m is u by 2. The final velocity is u by 2. The only catch is center of mass is somewhere here. Bas, wo catch tha. Center of mass is not there anymore. It is somewhere else. Find omega. Get it? Just give it a try. I'll get some water and come. Center mass is at right 3 L by 4 L by 4. See. So if you try to see the center of mass just before collision, they're almost touching here. This guy is going with you. The center of mass will be here. If you remember, that would be L by 4 and L by 4. This is your center of mass. Step 1, conservation of linear momentum. mu is equal to 2mvc by m. आगे एक step में. Next thing, torque about center of mass is 0. You can take any point. I'll take center of mass because it's actually rotating about that point, and this whole setup is rotating with omega. L initial is equal to L final. So initially, what is the angular momentum? It is just translating. This guy is L by 4. So mu L by 4 plus this will be half ICOM omega square, isn't it? Half ICM omega square, no? Because that MRVCM transition part is 0. Since VCOM passes through center of mass. अब भी थोड़ा मोमेंट ऑफ इनर्शिया कैलकुलेट करने में थोड़ा हेडेक है, but not difficult. You can calculate for one rod, that will give you the second rod also. So this is the center of mass. So this is here. So what is this distance here? That would be L by 4, L by 2, L by 2 ka, L by 2 ka half. So this distance will be L by 2 root 2, isn't it? L root 2 by 2 by 2, so L by 2 root 2. Perfect. That is your distance D. So I center of mass will be ml square by 12 plus md square, which is ml by 2 root 2 whole square into 2, because there are two rods. कितना आएगा ये? That case ml square by 8. 1 by 6 plus 1 by 4. 10 by 24. 5 ml square by 12. And you're done. So MUL by 4 is half 5 ml square by 12 omega square. There you get omega from here. 6 होगा वो, that is 6U by 5L. Please check. Are the steps clear, everyone? And think about it. There's nothing there. Momentum, right? Here we are not using restitution. Why? When you say it is sticking, it is taken care, right? E0, it is taken care when you say the word it is sticking. Please check. I'm telling you again, whatever questions we did, right? Today class, last class, and this class, you guys need to take a paper and sit and try to solve them on your own again. Now, when you're listening, you feel like you understood, but I know you're finding it thoda difficult or might be a little weird. But I know at the end of the class, I'm sure you're understanding after explanation. But I'm telling you, if this comes in the exam, strike nahi hota immediately. So that is the reason you need to do all these things again, right? Take a paper, see the question, and try to do. The process is important, because exam they might not ask like this. They'll ask you something else. Exam they'll ask you like this. They will say there is a rod like this, and there is one more L-shaped rod like this. They both collide. This is going with you. This is going with you. After hitting, it becomes a square, isn't it? The question will be different then, but the idea is still the same. The center of mass will still remain same, na? What will happen to the center of mass for this? Center of mass will be at rest, isn't it? So this square will be at rest, and the square will simply rotate. There's no translation. Making sense? The questions can be framed anyway, but the basic idea you should know, like boss, drawing. See, I'll tell you, no matter which question I gave, step 1, final diagram is important. Observe करके देखो. Every question, that's the main thing. Final diagram is important. Then you see whether forces are zero. Can you conserve energy? Can you conserve angular momentum? Let him give any nonsense question. The idea is always the same. The basic things are always the same. So if you always work on your basics, right, no matter what kind of question is given, you can figure it out. So you need to solve these questions repeatedly, like once or twice again. It is not like ratta mara nahi hai. You know, tomorrow if you're an architect, they'll give you 100, 200 buildings for you to redraw multiple times. Not that you will by heart those diagrams and you'll go and reproduce them. The idea is to take out concepts or ideas from each problem. Like, isko aisa problem hai to aisa kaisa karna hai. You choose different problems, and when something new comes, you will mix up and do it. Clear with this? Take a break. Come back by 5 p.m. Any doubt so far? Any step you can't get? You're asking why can't we conserve angular momentum about the endpoints? You can, but then the problem would be If you take about this point, then you have to find angular momentum of center of mass plus angular momentum about center of mass. Yeah, that should also work actually. That would be easy enough for moment of inertia. Hmm. You should get the answer actually. You're not getting? Initially angular momentum कितना होगा? Zero ना? Final will be how much? Maybe you forgot to take the masses 2m. Or did you take masses 2m? That will be 2 Vm COM L by 4. Direction reverse होगा. It will be this way and omega is this way. So subtract होगा. Then this will be ml square by 3 into 2 times into omega. 5 नहीं आ रहा है ना? Or did I mess up the moment of inertia का term? This is right. Moment of inertia here. This is L by 2, L by 2. So this is it is L by 2 root 2. Did I mess up any calculations? ML square by 12 plus MD square. That would be 1 by 12 plus 1 by 8. 1 by 6 plus 1 by 4 only, no? 2 square is 4 into 2. That will be 4 plus 6, so 10 by 24. That looks right. Angular momentum at this point will be angular momentum of center of mass plus. That is wrong, Nare. Dekho. What is angular momentum about this point? Angular momentum of center of mass, 2mvcm L by 4 plus angular momentum about center of mass, na? Again, you have to come back here only, na? So end of the day, कुछ फायदा नहीं हुआ. You can't take angular momentum about this point. It is not pure rotating about this point. You can't say I about this point into omega. That is a mistake we are doing. Making sense? Angular momentum about that point will be angular momentum of center of mass plus ICU omega. End of the day वही आएगा वापस. That point, this corner is not IAR. You can't do that. वो लॉजिक था. चलो कैमरा ऑन है भैया. We have a rod here which is hinged. Mass and length. Ball of mass in comes with speed u and collides with the rod, and distribution is e. Let this distance be x. So the first question is find x. If there is no hinge reaction during collision. This point, right, is also called as point of percussion. In cricket, na, they call this thing the sweet spot. Ever heard this in commentary? The ball is hit the bat on the sweet spot and it is gone and fly off. Karke. There's a good statement out there. That means if the batsman hits the ball on a particular spot, if you assume these are his hands and this is the bat, if you can hit a particular spot on the bat, his hands will feel no hinge reaction. Just think about it. It looks easy, but if you think about it, a ball coming at a speed of 140, 150, you're hitting a 6 or a 4, you're changing a lot of momentum. That puts a lot of pressure on your hands. But I'm saying there is a particular point on the bat. If you can hit somewhere there, the hinge reaction or the force on the batsman hands will be almost negligible. That way, batsman can play for much longer. Like it's not a joke, hitting 100, 120 balls with such a high velocity. So that's what we call as a sweet spot on a bat. If you can hit there, you can really swing the bat really hard, and the ball can go, without hurting your hands. So in cricket, we call this sweet spot. Point of percussion is a more technical name. Find x if momentum of the system increases after collision. This will be a good, matrix matching. Let's do the A part first. Find x if the hinge reaction is 0. You need to think like this. Why are you getting the hinge reaction in the first place? Start from that point of view. Tell me this thing. Why do you get a hinge reaction in the first place? Suppose, think like this. If you're catching let's say if you're catching something, right? If this point is trying to move, then there'll be hinge reaction, right? So what if during collision, the velocity of the point, if that becomes the IAR, or if that point ka velocity is 0, then is there a need for hinge reaction? You get the point? So that means during collision, if the velocity of that hinge is 0, then there is no need for hinge reaction. The reason you get hinge reaction is because that point is trying to move, but you connected with a rod and that can't move, so that is creating a hinge reaction. So if the velocity of the rod is 0 at the hinge, That is, it is not trying to move only. Then why will the hinge apply any force? If you try to move, there's a opposition. Then there will be no hinge reaction. That means if you remove the hinge and during the collision, that point will have zero velocity. There'll be no hinge reaction. Now, since there is no hinge reaction, so I can do this thing. So this is what is happening. This is going with you. This is before collision. So after collision, let this guy be u1, this guy be v1, and this guy be v2, and this rotate with omega. So this point of velocity should be v1 and L omega by 2. So this condition is being satisfied. Is that making sense? If there was no hinge and if the collision happens and if this point is at rest, now tell me, if you put a hinge or if you don't put a hinge, does it matter? Logic समझ में आ रहा है ना? If that point is not trying to move only, what will the hinge do? The problem comes if that point is trying to move and you locked it with a rod there, then it will apply a normal reaction or something. Then let's conserve angular momentum about the hinge. Again, you can take any point here. Or let's take the point of collision only. Remember, this thing is L by 2. So this guy will be x minus L by 2. L initial, L final, the ball, which is 0, 0. The rod is initially 0. This guy would be MV1 x minus L by 2 minus k cap plus ML square by 12 omega plus k cap. And that term should be 0. Take V1 and substitute here. This will be M omega by 2. M gets cancelled. Omega L goes off. X minus L by 2 is equal to L by 6. X is equal to 2L by 3. Check it out. You can remember the result also. It's a good one. So if you have a uniform rod, the point of percussion is 2L by 3. That is where you want to hit anything so that your hands don't get hurt. So there. Quite useful when you're teaching someone how to go and beat someone. So helps. That is why you want to hit them 2L by 3. Check out the steps. Clear with this? Everyone got this problem? Again, we're still playing with the rod and the ball only, but it's a different variation. Instead of asking which point has 0, here I'm giving you velocity is 0. Now, something more interesting happens here. So that means if x is equal to exactly 2L by 3, you have V1 is omega L by 2. Therefore, hinge reaction is 0. And therefore, F external is 0. So linear momentum is conserved. So even though there is hinge, the momentum of the system does not change. This itself will be a very good question. Where should the ball collide so that the momentum of the system is conserved? Now something interesting more happens. Suppose if x is greater than 2L by 3, then you will get V1 is greater than omega L by 2. What is it? The reverse. If V1 is greater than omega L by 2, X is greater than 12 by 3. It will become more in the denominator. So V1 should be less than omega L by 2. Now, in this case, see what happens. Less than or greater than. So V1 is omega L square by 12 into X minus L by 2. If X is 12 by 3, they'll be equal. If X is greater than 12 by 3, this value will be less negative, lesser. So V1 will be even, it should be greater. V1 will be omega L by 2. That means, see, this is a good one. So that means for this rod, this is going with V1. This is omega L by 2. So this point, let's call it A. A is trying to go forward. That means the hinge will oppose this way. If I try to pull you forward, the hinge force will be backward. Therefore, hinge will push to the left. And if you see, so this hinge force is opposite to the momentum. Therefore, momentum decreases. The system ka momentum decreases in this scenario. If X is less than 2L by 3, then V1 will be omega L by 2. That means the topmost point on the rod is actually trying to go backward. So in this case, the hinge reaction will be forward. So in this case, momentum increases. J tries to go back, hinge forces forward. Therefore, momentum increases. So depending on where you hit, you can increase or decrease the momentum. Have a look at this. This is how they can frame questions in matrix matching. On the left hand side, they'll give X is equal to 12 by 3, less than 12 by 3, equal to 12 by 3. And the right side options will be energy is conserved, momentum is conserved, momentum increases, momentum decreases, blah, blah, blah. You can ask. Angular momentum is conserved. Multiple things you can ask. Most people read this part is fine. This becomes a very interesting question. Is this logic making sense? If that point A will try to go forward, hinge will pull you back. If the force is backward, momentum decreases. If the point is trying to go backward, the hinge will push you forward. That means there's a force in the forward direction, momentum increases. Please check. This is again a proper advanced question. All clear with this? Any doubts? Ekanksh, Ronak, clear with this? Clear? Next thing. Next one is pretty good, right? This is another proper paragraph level question. Top view. We have a rod here, mass m, length 12. There's a string here of length L, and there is a mass m here. This is given speed u. So if I give speed u, it would go and exactly hit in the center like this. And E is equal to 0, means after hitting it sticks. And this whole setup is placed on a smooth ground. Find tension in the string. Initially, just after giving speed u. Find omega of the rod after collision or after ball sticks to rod. Let's get this. Especially the first question is pretty good. Are you getting the scenario? We have a rod, mass m, length 2L. On the end, there is a string perpendicular to it, length L, and there is a mass m, same mass. So it is given speed u. So the moment it tries to move, the string also will pull. Something happens. So find the tension in the string initially, and find omega when the ball sticks to the rod. Let's get this. Did you get the tension, anyone? First thing I'll tell you again, see. What did I ask you? Find tension. Can you find tension using conservation? No. So what should you do? FBD. Did you draw an FBD? See, me why bol raha hu. It's okay if you don't get an answer. But if there are 5 steps, figure out the first 2 steps. The basic foundation should be clear. The moment you see a question, you should be able to categorize, boss, this belongs to torque and force. This belongs to conservation or whatever. Draw a diagram. Start from there. Then you will start seeing things. And at some point, right, this will become a habit for you. When you see a question, you know what to do. This is what you should reach in the final exam. If you see all these people who crack the exam, right, the moment they see the question, they know what to do. It doesn't take more than 10 seconds to figure out what to do, what steps are there. After that, solving me, they might get stuck and they might mess up. That's a different story. But if you go to any topper there and if you ask their right, any people with physics, mein, they will, the moment they see the question, they know how to do. And advanced may, no matter how tough questions they give, if there are 20 questions, there'll be at least 14 to 15 questions you must have seen them somewhere. So what differentiates in the top 1,000 ranks is the remaining 5 questions. But first to reach 1,000, to pehle 14 questions to karna hai. And those will be pretty standard models. The moment you see them, you should know what to do in that question. And the amount of work we are doing in the class, right? Aram will handle that 15 questions without a problem. And I'm building the foundation for the remaining 3-4 weird ones which might come up. Uske liye alag se we have to do the, those things we will work only after the mains gets over. After the first attempt gets over, then we start working on those kind of problems. Right now, your target is that first 14, 15 questions, which are like some standard models. You see a question, you should know what to do. When I say standard, na, at least A level of question. You see, though, you should know what to do. The steps you should know. So what to do? You have to draw an FBD. There's a story there. So let's draw an FBD. Forces, tension. That's it. There's only one force on the rod. There's a tension. Now, this point also has acceleration ACOM, and this thing also has alpha. This is where the problem comes. देखो क्या होगा. So this point A here, which we are talking about, this guy is not at rest. This has an acceleration ACOM plus L alpha by 2. Agreed? Now from here, if you see, that means, now you tell me, this is going in a circle with respect to whom? A thinks the ball is going in a circle, right? Not in the ground frame. Point A thinks the ball is going in a circle. That means our observer is standing on A. But A is a non-inertial frame. That means I have to use pseudo force. So what is the pseudo force? Mass of the body into acceleration of A in the opposite direction. This is the pseudo force. Next thing, since it is going in a circle, there will be a centripetal acceleration, which is U square by L, because it is going in a circle. There are actually two accelerations here. One is a pseudo force and one is a centrifugal force. I'm using centripetal acceleration here. Or if you want, I can do that also. I'll use centrifugal force. Because you're going in a circle, there'll be a centrifugal force away from the center. Let me use acceleration only. The biggest mistake people do, they forget that A is also moving. There. If you have done this, you got the FBD. Question ho gaya actually. Now, if you look at the rod, the forces T is equal to mass into A center of mass. That's for the rod. And T into L, remember this distance is L, total length is 12. T into L will be, that's the torque, is ICOM alpha. So T into L will be M into rod ka length is 12, ML 12 square by 12 alpha. T is equal to ML by 3 alpha. And for the ball, T plus mass into acceleration of A is equal to mass into the centripetal acceleration. So tension, acceleration of A is A center of mass plus L alpha by 2 is equal to mu square by L. But what is MA? MA is nothing but T. And what is ML alpha? ML alpha is 3T. ML alpha is 3T. That would be 3T by ये L alpha होगा ना? Because this length is L. Perfect. So that is 3T is equal to mu square by L. We get T is equal to mu square by 5L. Clear? And I'll tell you one thing, this is not new. We have done this before. You just don't realize it. Isn't this the same question where we did? The question was find the tension in the string just before collision. What did we do? We said, because you're standing on B, which is accelerating, pseudo force tha or centripetal acceleration tha. Wasn't this the same question? Check it out. Idea was the same. 25th question of this. This is what I was saying. Ideas do keep repeating. The only difference here was that the rod was rotating to A plus L alpha aa gaya tha. But this concept of applying a centrifugal force and a pseudo force and this thing, we did this before. Please check it out. It's a pretty good one. Everyone got the idea what is happening? Simple. It is going in a circle. Great. But with respect to whom? With respect to where? Ground frame में circle में नहीं जा रहे हैं वो. But the moment you go and stand on it, it became a non-inertial frame. You have to apply pseudo force. And that pseudo force is coming because this tension is pulling the rod also. So that rod created a COM and alpha. So from there I got a acceleration of a, and then we did it. Check it out. This is what I was saying. All these problems you should take a paper and try them on again. Without that, these things will never, you will never grasp them. Is this question clear? Check out the steps. It's a pretty good one. Question is still not over. Find omega when this thing goes and hits. Find omega when the ball goes and sticks to the rod. Now we want final omega. Look at the word final, means it's talking about conservations. Question ka the words are important. Maybe you guys are not realizing now, but when you make it a habit, right? In the exam, the moment you see the question, you know what to do. In the final advanced exam, the way the papers are coming, your chemistry is supposed to get over in 40 minutes. Physics should get over in proper 1 hour. But every year your senior says, sir, paper was lengthy. It took proper 1 hour to finish it off. Even the fastest of the students. Your max will take 1 hour, 15 minutes. And max is a rank deciding factor. Without physics and chemistry, you won't even enter 3000 ranks. The top 1000 ranks will be decided by max. Simple reason. Everyone loves physics in the top 5000. Sabka favorite subject physics hai. Maximum people. So no matter how tough the paper is, they will solve it. The max becomes a rank deciding factor. Next thing. So how do you do this thing? The second part. Again, if you draw the diagram, you'll understand. So this was a rod. This was him. This was him. So for these two guys, the center of mass is here, which is actually going with u by 2 because the mass is this thing. So this system will go in such a way, the center of mass will continue to go in the same path. So finally, when this ball goes and collides, this is how the diagram looks. Isn't it? Because the center of mass always has to go in the continuously path. No? The center of mass is unaffected. Is that making sense? So when the ball goes and collides with the center of the rod, tell me one thing. Where is the initial center of mass here? If the ball goes and sticks here, where is the center of mass here? No? But you said the center of mass will follow the same path. So this red line here is the path of the center of mass, which is unaffected by internal collisions. So this is the diagram when the ball collides. You're done. Conservation of angular momentum about center of mass. The initial angular momentum mu by 2, because this is L by 2, is equal to ICOM omega. Ball is anyway 0. It is at the same position. So rod is M 12 whole square by 12 omega. M goes off. Q, that is this is L square omega by 3. Omega is 3U by 2. Check. That is actually the easiest one. Because if you take angular momentum about center of mass, the ball is at center of mass, तो उसका मोमेंटम हमेशा कुछ होगा नहीं. Only for the rod it will come. So this is how it looks when the ball collides with the center. Ball collides at the center of mass of this rod. Clear with this? That's about angular momentum conservations. Next thing, angular impulse. Have a look at this. Clear till here. Any doubts on this? Aryan, Ayuth, clear with this? Clear, na? Venkatesh, Rehan, Sauja. What is angular impulse? Simple thing. Angular momentum. We have written this before. Angular impulse, which is simply change in angular momentum. So we know torque is equal to dl by dt. So change in angular momentum is integral torque dt. So we can write this thing as r cross f dt. And we know f dt is nothing but r cross r, where bar is nothing but integral f dt, which is change in linear momentum. So this is the relation between angular momentum and angular impulse. So integral r bar cross j bar is equal to delta L bar. So in the questions, they will mention as impulse is j karke. Again, r bar is what? R bar is a vector from axis to the point where impulse is given. Impulse means think like this, when you're hitting your carom board, the striker, the flick is an impulse. Vector from axis to point where impulse is applied or force is applied. You can simply also write this thing as the perpendicular distance, if j is constant, into j, r perpendicular into j is equal to change in angular momentum. So r perpendicular from center of mass into j gives you change in angular momentum about center of mass. Center of mass is the safest point. Have a look at this. Let me show you an example. Yeah, so impulse meaning same thing. No, it's a large force for a short time. That is impulsive force. Impulse is simply change in momentum. Have a look at this. Clear? Let me show an example how questions can be framed on this. Example, they'll say like this. There is a solid sphere. This is rough. So someone will say an impulse j is given at a height h. This is how the question will be mentioned. So they'll ask you find V, COM, and omega just after impulse. I think after a long time it will start rolling and all will happen. Now this is how you do see. Let the final velocity be V, COM, and omega. So here during collision, right, there is an frictional force. But if you observe here, F is non-impulsive, so we don't consider it as too small. F is non-impulsive, so we can ignore it. It's a very small time. So simple steps. First step, whenever you get impulse, what is impulse? Impulse is change in momentum of center of mass. So that would be mvcom. Therefore vcom is equal to j by m. आगे एक step में बस यही करना था. Second thing, angular impulse. So change in angular momentum about center of mass is j into the perpendicular distance h. J into r perpendicular from center of mass, which is j into h, is equal to ICOM omega, because initially it is at rest. So omega will be jh by m, solid sphere na, 2 by 5 mr square. That's your omega. Done. So after this, now because v is not equal to r omega, the friction will be mu mg. It will skid us, it will roll, all that will happen. Then the question becomes like this, the coin question which we did today. It will become like this. So this is the velocities just after collision. After, if you give some time, the friction will come into the picture and mess up the whole thing. Just after impulse. That no slipping, gipping, nothing you will do. Impulse is simply change in linear momentum, angular impulse is change in angular momentum, story done. Have a look at this. Clear? Now let's see, you guys try. I'll give you one. We have a rod here, mass ml. This is your origin. This is point A, which is 0 comma L. Gravity is there. This is like a table here. And someone gave an impulse here at the top, J. Basically, you hit it like a striker, you flicked it. Impulse J is given to end A. So then what will happen? This rod actually starts rotating. This is what happens. That rod will start going, translating and rotating. Find the coordinates of A as function of time t. You can choose this as x-axis and this is y-axis. So if the rod is rotating and going, find the coordinates of A as function of time t. And again, this is not new. You know where you have done this? The first question, center of mass. Remember this? Coordinates of A. The center of mass will go in a parabolic path and it will rotate in a circle about this thing. So it's a parabola plus a circular motion. Try. Step one, find the velocity of the rod. Find omega of the rod. Once you get the question is done. Try. You got a minute. Advanced my rotation every year, you get at least 2 questions minimum. It can go up to 4 also. This is a pretty good high weightage. In entire mechanics, this is a good weightage. First, find the velocity. So J will be, so just after collision, this guy will be V and this will be omega. So J is delta P, which is MVCOM. Again, V is J by M. There's nothing there. Next thing, J into L by 2, perpendicular distance from center of mass, will be delta L COM. This will be ml square by 12 omega. So omega bhi aa gaya. 6J by ml. Then what to do? So I know these coordinates will be 0, comma L by 2. So after some time t, projectile motion. So I'll call this point as C. If you look at the coordinates of C, the horizontal distance will be Vt, comma, the vertical distance will be L by 2 minus half Gt square. Agreed? Isn't that the horizontal distance Vt and half Gt square? Projectile motion, na? Horizontal projectile. There's no vertical velocity. And then let this rod become like this. A. So this rod A is rotated by an angle theta, where theta is equal to omega t. So this point A coordinates will be, this will be L by 2 sine theta, and that vertical will be L by 2 cos theta. Therefore, the x coordinate of A will be Vt plus L by 2 sine theta, where theta is omega t. Y coordinate of A will be L by 2 initial height minus half Gt square, the height has fallen down, plus L by 2 cos theta. You might get a doubt, sir, how do you know it is like this? It can be like this. Don't worry, the theta will become obtuse angle and the sine will become negative. You take theta as acute and solve the problem, the sines will take care of it. If it really goes down, then theta will be obtuse. Then cos will become negative. Check. Idea clear? Find the coordinates of the center. With respect to the center, A will go in a circle. Find the coordinates. Add them up. Clear? Everyone got this? Turn the page. Last one for the day. Last question for the chapter. We have a ball here. People are so happy when I say last question. इतना थक गया क्या? Was the class too heavy today? You'll get used to it. Remember, I told you when we started, rotation is the peak. After this, things will be a little better only. So this guy is going with U and rotating with omega. Friction is mu, restitution is E. Getting it? It's a solid sphere, mass and radius are, and the ground is rough. So a ball collides with a rough floor as shown. Find velocity and omega of the ball just after collision. And the point where it lands on the ground after the first collision. So something happens actually. This ball will hit here and will fly like this projectile. And you have done this multiple times. Maybe you didn't realize. Kabhi kiya aisa? You're standing like this. You take a ball. You drop it down with a spin. It falls and comes towards you. Done that? It's the same question. You're dropping a ball with a spin. It falls on the ground and comes towards you. So this ball will fall down and will jump like this. Finish up. Last one for the day. This is a pretty good one. Out of all the questions, impulse questions are the most weirdest ones. In that, it is coming in angular momentum, which is another weird one. This is weird square. So let's get this. It's a good problem to wrap up the chapter. You'll have kinematics, you have NLM, you have friction, you have collisions, you have rotation, obviously. Six chapters, I guess. Step one, draw the final diagram. Start from there. Try, I'll give you 5 minutes. Let's go one step at a time. First in the diagram, see. Just after collision, this guy will have a speed Vy. This guy will also have a speed Vx. And you also have a omega final. Why will you have a velocity in the horizontal direction? Because there is a force normal reaction and there is a friction also, isn't it? Think about it. When this guy is rotating like this, isn't this point slipping? To stop that slipping, the friction will come. That friction will actually give you horizontal velocity. This is the reason why when the ball falls, it comes towards you. And this is the concept behind a spinning in the cricket. When these people throw the ball and spinning, if you give an omega like this, when the ball falls on the ground, the friction will be towards this side. So the ball falls here and goes this way. Suppose if you throw the ball this way and if you give a spin this way, the ball falls here and goes this way. This is your leg spin and this is your half spin. That's the whole concept in cricket. The entire spin bowling is based on this concept. Great. Now what? Collisions. If you remember this concept here, if you have a wall here, if you go with speed u, hit the wall, you bounce back with eu. So here you can clearly see Vy will be eu. This guy will be E into u. So देखो Vy आ गया already. Then we will take impulse in vertical direction. What is the vertical force? Integral ndt. That should give you change in momentum in y direction. That is final minus initial. That is mvy minus of minus mu. You have done this kind of questions in impulse, which is mu into 1 plus e. This is equation 1. The horizontal direction integral f dt will give mvx. But integral f dt is mu and dt. Again, we are assuming this is max. So this will be mu and dt is mu by 1 plus e. This gives me a horizontal velocity vx. I know Vy, I know Vx. Check the steps. We still have to find omega. This is how you do impulse problems every time. You draw the forces and you take the force into integral. We're not going to integrate anytime, so don't see the integration and get scared. That f dt will become du and dt and ndt goes off. Any doubts on these steps? So people think question gets over here. No, there's a trap. The next part. Now to find omega, what we do? This guy is coming with you, and this is rotating with omega. This is the point of collision. Remember, N also acts here, F also acts here. So torque about A is 0. Therefore, L about A is conserved. So after collision, this guy is going with Vy and this guy is going with Vx and this is omega dash. So initial momentum is equal to final angular momentum. The initial will be angular momentum of center of mass. It is passing through this, that is 0. I cum omega, that would be 2 by 5 mr square omega minus k cap. Final angular momentum Vy is 0. Mvx perpendicular distance r minus k cap plus 2 by 5 mr square omega dash minus k cap. 2 by 5 mr square omega minus mvxr. Vx का value already calculated. 2/5 mr square omega dash. So omega dash will be omega minus 5Ex by 2R. That's your omega dash. And I know Vx, so you can take Vx from here and substitute. 5 mu u1 plus e by 2R. That's your omega dash. This comes from conservation of angular momentum. But there is a problem now. All this that you did is valid only if Vx is greater than equal to R omega dash. This is important. What happens? Are the steps clear? Conservation of angular momentum. What happens if the moment when Vx becomes equal to R omega dash? Tell me one thing. The moment this Vx and R omega dash become equal, won't the slipping stop? Slipping stops. If the slipping stops, will the friction act? And friction will stop acting. That means throughout the motion, friction is not there. Friction stops acting. Therefore, friction acts only for some part of the collision. For some time during collision. So your equations will become like this. Integral n dt will be mu plus 1 by e. This is fine. Now friction will be F max. Friction is maximum, but it will act only for time dt dash, which is mvx. Now I can't solve this. Dt dash is time for friction, for which friction acts. And here dt is greater than dt dash. Dt is the time for the time of collision. This is why, yeah. If you have more friction, you'll get more spin, na? But luckily, if you observe, omega dash will still remain same. Omega dash ka this Vx will change. So this equation is still right. This is always valid. But Vx ka formula changed. But luckily, I know the answer for Vx already. So I know Vx is equal to R omega dash. I know Vy is equal to U. And I know omega dash is omega minus 5Vx by 2R. So if you solve them, I'll get my new Vx and new Vy. So you have to check here. After doing this now, you have to check whether this omega dash is it greater or less than Vx. If Vx is greater than R omega dash, your life is happy, question is over. But if it is less, you're dead, you have to go back again. You will not do the whole problem again. You can still use this result, but you lost this result. This will become wrong anymore. But in return for that, you got one more result. You got Vx is equal to R omega dash because the friction stopped. Are you getting what happened there? And हमने किया था ऐसा question, where we did again same thing collisions में. That impulse problem is same thing happened when the bullet is hitting the thing. Let me show you where it is. Do you guys remember this question? Same thing we wrote. See, valid if the horizontal velocity is greater than 0. If it is less than, there will be no horizontal velocity. The ball will fly straight. Oblique collisions में क्या था impulse based problem? Something similar. And done. So where will it land on the ground? So after collision, we got this is Vy. This is Vx. So it will go and somewhere fall on the ground. So range will be horizontal velocity into time of flight. Time of flight is nothing but 2 v vertical by g. That gives you the range. Are you clear with this? It's a pretty good one. That's a deadly problem. I have seen people figure out till here. This thing after this, people go up. They forget that condition. There's a chance it can stop slipping in the middle. Clear with this? That is the last one for the day. And that with that, we have done with rotation. So next class, we'll catch up again on Tuesday. We'll be starting with ray optics. Now, there are few students who are already done with that in the other batch. You guys can attend if you want, or you can take a break next week. I know you have major test also coming up. So that is up to you. I will leave it to you. So next Tuesday, we'll be starting with ray optics, another important topic. You will have a more comfortable life. It is just based on formulas. One of the favorite chapter of medical students. It has just a bunch of 17 to 18 formulas you need to mug up and results. That is another